Hi, this is Drupad Patel, and today I am going to give you a small presentation about the wastewater treatment plant. Today we are generally discuss the basic phenomena of the wastewater treatment plant. What is happening in the wastewater treatment plant? So first of all, as we all know, water is the most precious element on this earth. Actually, 70% of the earth's surface is covered by the water. But out of these, only 2.5% water is a fresh water that is potable for the human uses as well as the other living organism uses. So to preserve the freshwater sources as well as to reuse that used water is is prime responsibility of the humans. So first of all, what is wastewater? Water, which is water that is contained any type of organic material as well as suspended solids as well as dissolved solids, is called as a wastewater. And to treat this water and to remove these all impurities from the water is known as a wastewater treatment plant. Generally, there are two types of wastewater. First one is industrial wastewater, that is come from the industrial manufacturing industrial sources, and is generally known as effluent, and the treatment of that plant is known as effluent treatment plant. Domestic wastewater is generally come from the residents, is generally known as a sewage, and the treatment of this sewage is known as a sewage treatment plant. Now, what is wastewater treatment? Wastewater treatment is a process to remove the contaminants in the form of organic matter, suspended solids form, or in the dissolved form from the water, and to make water again usable with minimum impact on the environment is called as a wastewater treatment. Now, sewage is generally, as we discussed in the first slide, sewage is generally came from the residents. Some example of these are human and animal excreta, and water used for the washing purposes, bathing purposes, and cooking purposes. And the industrial wastewater is generally came from the manufacturing industry such as slaughterhouses, dairy industries, textile industries, food industries, etc. Now, what type of contaminants are generally present in the water? So, as we discussed that there are dissolved contaminants are present in the wastewater. Dissolved contaminants are such as cations and the anions, any type of cations or anions. Suspended solids such as sand, stones, dirt, sleet, larger debris, anything that is suspended in the water. Uh, Organic contaminants such as pesticides, herbicides, dyes, color compounds, ethanol, methanol, etc. Organic contaminants. Sometimes wastewater also contain pathogenic bacteria also. Now, how water can be treated? So, the treatment methods. There are mainly two types of treatment method. First one is aerobic treatment and the second one is anaerobic treatment. As the name suggests, in the aerobic treatment, there must be a presence of oxygen is required. So, whatever the degradation occur of the organic contaminant, that is in the presence of oxygen. In anaerobic treatment, there is a strictly absence of oxygen is needed. In the absence of oxygen, the anaerobic bacteria can break down the complex structure of the organic compound into the simpler form. But for the higher efficiency of the treatment plant, there must be a present of aerobic treatment after the anaerobic treatment. What I am trying to say is, first first place the anaerobic treatment, then after aerobic treatment, and finally water can be reused for the some purposes. Today we are mainly discuss about the aerobic treatment only. In the aerobic treatment, there are mainly three subdivisions. First one is primary treatment, which is also known as a chemical treatment. Second one, secondary treatment, which is also known as a biological treatment. And the third one is tertiary treatment. Now, what is happening in the primary treatment? In the primary treatment, there is a removal of sand, gravel, rock, sleet, and larger debris by putting the mesh in the flow of water. Even Fat and oils can also be removed in the primary treatment by the oil skimmer or by any other chemical means. Secondary treatment. Secondary treatment is also known as a biological treatment. The example of these are activated sludge process, trickling filters, and the oxidation ponds. As the name suggests, there is an active biomass present in the water in the presence of oxygen to degrade the organic contaminant from the wastewater from the water. Now finally, tertiary treatment. In the tertiary treatment, there are filtration units to remove the suspended as well as the dissolved solids from the water. The example of the filters are sand filter, multigrade filter, reverse osmosis, ultrafiltration. In some places, if we are trying to reuse the water for the drinking purposes, there must be a presence of disinfection plant. The disinfection treatment are done by the chlorine treatment or by the UV radiation treatment. Now, what is generally happening into primary treatment? As we discussed in the third slide, that in the primary treatment there must be a removal of larger debris by putting mesh or the bar screen in the flow of water, which is shown in this figure. You can see it. It is not necessary that wastewater pH is always a neutral pH, and there is a basic primary requirement for the aerobic treatment for the activated sludge process, that pH of the water must be a neutral. Sometimes the wastewater pH is slightly acidic or highly basic, so we have to maintain the pH in the neutral. So for maintaining the pH at the neutral side, we have to add some chemicals like acidic chemicals or basic chemicals, whatever requirement is there. Some industrial effluent is highly contaminated, so it cannot be directly treated by the secondary treatment. So for this, there must be a requirement of some chemical treatment in which there are addition of coagulating agent as well as the flocculating agent. Now, what is this coagulation process? So in coagulation, there is addition of coagulants such as alum, which has a positively charge on that surface. So it can attract to the negatively charged particles into the wastewater and forming the flocks. These flocks are too lighter in the aqueous form, so making these flocks heavier, and to settle it down at the bottom, there is the addition of flocculating agent. The example of flocculating agents are polyelectrolytes, which can bind with these flocks and make it larger flocks and make it settle at the bottom, which is shown in the figure at the sedimentation tank. And the water that is effluent from the surface is going for the further treatment in the aerobic treatment, that is activated sludge process. The figure shows the primary sedimentation tank. Whatever the water treated with the primary treatment with the chemicals is enter into this tank, and the flocks which are generated is known as a chemical sludge. It settle at the bottom like brown color, and this sludge can be removed by the various means, and the clearer water from the surface is further going to the next treatment, like in the aerobic treatment. Now, activated sludge process. Water can be treated in the activated sludge process in the presence of oxygen and with living microorganisms such as bacteria. Now, which components are required for the activated sludge process? The first one is aeration tank or the biological reactor where this process can be occurred. Second one, an aerator or the diffuse air supply, which can supply the fresh air or the oxygen. Third one is secondary clarifier. The secondary clarifier mechanism is the same as we discussed in the fifth number slide, that is like a primary sedimentation tank. It is the same mechanism of the primary like primary sedimentation tank. And the fourth component is return activated sludge process. So what is the difference in primary sedimentation tank and the secondary clarifier tank? Whatever the sludge is generated in primary sedimentation tank is can directly be removed, can directly be removed. But in the clarifier, whatever the biological sludge is collected at the bottom is returned back to the aeration tank for the further treatment of the new wastewater. Now, what is actually happening in activated sludge process? In aerobic bacteria in the aeration tank, they generally use organic contaminant which is present in the wastewater as a food source, and these organic contaminants or a food source for the bacteria is known as a substrate, and this substrate can be utilized by the bacteria and generate themselves and convert organic contaminant into the simpler form like carbon dioxide, ammonia, etc. Now, how can we decide that our activated sludge process plant or a wastewater treatment plant is running smoothly or is running efficiently? So there are some key characteristics that can be checked in the laboratory by the laboratory analyst, uh, and whatever the result is coming is compared with the standard range of the parameters. So there are some key characteristics that we are not going to be discussing deep, just to review this one. First one is MLSS, that is mixed liquor suspended solids. MLVSS, that is mixed liquor volatile suspended solids. The For this efficient running of the plant, there should be a range between 2000 to 5000 milligram per liter of the MLSS, and MLVSS must be present in the 7000 to 8000 milligram per liter. Third one is F by M ratio, that is food to microorganism ratio. These ratio should maintain between the 0.1 to 0.4. If there is overloading of organic waste and there is a least number of bacteria present in the water, there should be not efficient treatment of water can be happen. If there is too much number of bacteria present but there is a minimum load of organic load, so there is a scarcity of food can be happen, and this can be visibly seen by seeing the water. The water can become a brackish water. So we can directly check that this plant is not running smoothly. What's the main process of activated sludge process that I have shown in the slide? The food, which is present in the form of wastewater. Oxygen is present in the activated sludge process, and the bacteria, which can use this food and oxygen and convert this food or organic contaminant into the carbon dioxide, ammonia, and multiply themselves, so generate the new biomass and another end product. Some of the parameters to check the water qualities before treatment and after treatment are as pH, TSS, that is total suspended solids, total dissolved solids, chemical oxygen demand, biological oxygen demand, dissolved oxygens, sodium absorption ratio, nitrogen, phosphorus, chloride, alkalinity, grease, etc. The figure shows the activated sludge reactor. From the left hand side, what is primary chemically treated is coming from the left hand side, enter into the aeration tank where there is a aerator is present to supply the air or oxygen, and the biomass is present, and the treated water is goes to the clarifier, and in clarifier there is a sedimentation of biomass or a sludge which is returned back to the aeration tank for further treatment of new wastewater, and the clearer water is goes for the further treatment if required. Now tertiary treatment. So biologically treated water enters into the tertiary treatment. Tertiary treatment generally involves the sand filters, carbon filters, and the multigrade filters, and the reverse osmosis. The sand filter can remove suspended particles up to 20 microns, and there are different size of stones and the gravels are present in the sand filter up to some height, so that water can forcefully enter from the bottom and again reverse back to the back from the top. So whatever the suspended particles up to that size can be removed in the sand filter. And carbon filter generally used to remove the odor and the color from the wastewater. There are same mechanism in the carbon filter, same as sand filter. In the the reverse osmosis is generally used to remove the dissolved solids from the wastewater. Uh, Dissolved solids are generally cannot be visibly seen in the water, and these can be removed by the osmosis phenomena. So these are the list which I have used to make this small presentation in front of you guys. Thank you so much for listening me, and I hope you can understand the basic phenomena of the general wastewater treatment plant. Thank you again.